Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Friedel-Crafts alkylation requires an electron-rich aromatic ring. The nitro group, NO2, is a strong electron-withdrawing group, EWG, that deactivates the benzene ring toward electrophilic aromatic substitution, EAS. Moving on to the next step. Identify the reaction type. The reagents are an arene, nitrobenzene, pH NO2, an alkyl halide, HCl, and a Lewis acid catalyst, UlCl3. This is a Friedel-Crafts alkylation setup. Moving on to the next step. Assess ring reactivity. The nitro group, NO2, is a powerful metadirector and strong deactivator. It withdraws electron density from the ring via both inductive and resonance effects, making the ring significantly electron-poor. And for the final step, determine feasibility. Friedel-Crafts reactions, both alkylation and acylation, do not proceed on benzene rings that carry strongly deactivating groups such as NO2, SO3H, ChO, COR, or CF3. The ring is too deactivated to attack the electrophile, ethyl carbocation or ET UlCl3 complex. Additionally, UlCl3 coordinates strongly with the nitro group, further reducing availability of the catalyst. Option A, PHNH. This would require reduction of the nitro group to amine and then enalkylation, which is not what these reagents do directly. Option B, no reaction, correct, because nitrobenzene is too deactivated for Friedel-Crafts alkylation to occur. Option C, ortho-metanitroethybenzene, would require successful EAS, which does not occur on deactivated rings. Option D, paranitroethybenzene, same reasoning as C, EAS cannot occur on the deactivated ring. Therefore, the correct answer is B. Therefore, the correct answer is option B.